let's try this again. So, OU factorization. So, one, 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 2, 1, 3, 3, 1, 2. Okay. So we want to eliminate that 2. So E21 is 1, 0, 0, negative 2, 1, 0, 0, 0, 1. One, 1, 1, 2, 1, 3, 3, 1, 2. And now that will equal 1, 1, 1. Okay. 3, 1, 2 is not affected. Okay. Negative 2 times 1 is negative 2. Negative 2 plus positive 2 is a 0. Negative 2 times 1 is negative 2. Negative 2 plus 1 is a negative 1. And then negative 2 times 1, that becomes a negative 2. Negative 2 plus 3 is a positive 1. Okay. All right, now this is E21 acting upon A. All right, so now we're going to take E31. Okay. 1, 0, 0, 0, 1, 0, negative 3, 0, 1. And we're going to have this act upon 1, 1, 1, 0, negative 1, 1, 3, 1, 2. Okay, and now this is E21A. Okay, 1, 1, 1, 0, negative 1, 1, negative 3, and add to a positive 3 is a 0. Okay, now negative 3 times 1 is going to be a negative 3, and a negative 3 plus a positive 1 is going to be negative 2. Okay. All right, so negative 3 then acts upon 1 is a negative 3, and a negative 3 plus a positive 2 is a negative 1. Okay. All right, now we're going to use the elimination matrix E32. Third row, second column. And so I'm going to have to multiply that guy by a negative 2. So that would be 1, 0, 0, 0, 1, 0, 0, negative 2, 1. Now this is going to act upon that guy right there, which is 1, 1, 1, 0, negative 1, 1, 0, negative 2, negative 1. Okay. And this is E31, E21A. And that's going to equal now 1, 1, 1, 0, negative 1, 1, 0, 0. And then negative 2 times 1 is a negative 2, and a negative 2, and a negative 1 is a negative 3. Okay. So we found U. Great, we found U. So what did we get from all of this? What we got from this is that E32, E31, E21A equals U. okay? So each of these individual matrices acting upon each other, I mean the elimination matrices acting upon A is going to give us U. And we have to do this in order, okay? So now, if I want to move these E's to the other side of the problem, okay? What would be the first thing I could do is I could start multiplying by the inverse of the elimination matrices. So if I multiply by E32 inverse, E32, E31, E21A would equal E32 inverse U. Okay, those guys will cancel each other out. All right, and then I can do it again, and I can say E31 inverse E31 E21A will equal E31 inverse E32 inverse U. Now let's cancel each other out. Okay, and now I can hit it with the last one. E21 inverse E21A is going to be E21 inverse E31 inverse E32 inverse U. And those will cancel each other out. Okay? So the LU factorization of this guy, what is the L? That's the L. So the inverse of the elimination matrices, those end up forming the lower triangular form of the matrix. Okay? All right, now we have to think about, well, how would I find the inverse of these matrices? Okay, well, let's just say, all right, it's actually pretty simple. Let's do it in a more formal environment. Let's look at, let's say E21 inverse. Okay. So, remember, how do I find inverse matrices? Well, what would I do? I'd take this guy, I would multiply by 2 and add downwards. So that would be 1, 0, 0, 0, 1, 0, 0, 0, 1. 0, 0, 2, 1, 0, 0, 0, 1. And so that this component right here, that is E21 inverse. Okay, so basically to find the inverse matrices of all the different elimination matrices, whatever your elimination component was, just change the sign. Change it from a -2 to a positive. If it's positive, change it to negative. That's it. Okay, so my E21 inverse, so A would equal, okay, so we got that first one, 1, 0, 0, 2, 1, 0, 0, 0, 1. Now acting upon 1, 0, 0, 0, 1, 0. So now we're at E3, 1, okay? And so, where was my E3, 1? Where you go? negative 3, so this is a positive 3, 3, 0, 1. Acting on E3 two members, which was 1, 0, 0, 0, 1, 0, 0, 2, 1. And now this is going to act upon our U, where's my U out? Which is 1, 1, 1, 0, negative 1, 1, and 0, 0, negative 3. Okay. All right, now what's going to happen with all of these? So when this first matrix acts upon this one, the only thing that's going to happen is it's going to say take the first row, multiply it by 2, and add it to the second row. So it's going to put a 2 right here. Okay? You know what, I'll write it up. So if I multiply this together, the first one I'm going to get is 1, 0, 0, 2, 1, 0, 3, 0, 1. Now acting upon 1, 0, 0, 0, 1, 0, 0, 2, and 1. Okay? And then this is going to have to act upon 1, 1, 1, 0, negative 1, 1, 0, 0, negative 3. Okay, so what's going to happen when this guy acts upon it? That's 1, 0, 0. Okay, so this row acting upon it takes the first row, multiplies it by 2, and adds it down 2, 1, and 0. Now this row acting upon it, the first thing it's going to do is that 3 is going to hit the 1. Let's add that one down there. 3, 0, 1 acting upon 0, 1, 2 is just going to pick up the 2, and the last one's going to pick up the 1. And now this is going to act upon 1, 1, 1, 0, negative 1, 1, 0, 0, and then negative 3. Okay. So now we're going to check our work. So this is L, this is U, this is 1, 1, 1, 2 times 1 is 2, 2, 1, 0, that's 2, and a negative 1, which would be a 1. And then 2, 1, acting upon 1, 1, negative 3, that's 2 plus 1, which is 3. Now 3, 2, 1, acting like that, that'll just give us a 3. And then 3, 2, 1, acting upon the middle one is a 3 and a negative 2, so that's a 1. And 3, 2, 1, acting upon 3, 2, 1, 3 and negative 3 cancel each other out, and that becomes a 2. And I believe that's the first matrix that we began with, which is our A. Okay, so that's just us checking our work right there.